Hi guys, so today we're going to learn how to make a tree diagram. Now, with tree diagrams, we use this to calculate the theoretical probability of an event occurring when there's more than one event. For example, this game, you have to spin the spinner each time, and in order to get a point or to win, you need to have a match. Now, in order to find the probability of a match, we need to use our theoretical probability formula, which is favorable outcomes over possible outcomes. Now, when we have more than one event, it's more difficult to see what the favorable outcomes are and the possible outcomes are, which is why using a tree diagram is a good technique. So to start by making a tree diagram, we're going to have spinner 1, and under spinner 1, I am going to put the 4 possible outcomes. So we have red, we have blue, we have green, and we have yellow. Now, we're going to have a second column that is going to be spinner 2. So this one was spinner 1, this one will be spinner 2. Now, if I spun a red and then moved on to the second spinner, I would have 3 possible outcomes from this. So spinner 2 has a green, a red, and a blue, and I am going to draw lines connecting those 3 things. And I'm going to actually put a start here and draw lines to my 4 starting possible outcomes. And I'm going to do that for every single outcome of spinner 1. So we're going to do green, we're going to do red, and we're going to do blue, green, red, blue, and then green, red, and blue. Now, in order to list our outcomes, I'm going to make another kind of list here and label it possible outcomes. And I'm going to follow my lines. So I'm going to start, and I'm going to go up to the red, and then I'm going to keep following it up to the green. So my first possible outcome is a red, green. And then I'm going to keep doing that for every single one until I have finished doing it. So I'm going to go up to red again. And then instead of going to the green, I'm going to go to the red. So another possible outcome would be red, red. And then I'm going to do it again. I'm going to follow it to the red, follow it down, so we have red, blue. And I'm going to keep doing that until we get to all the outcomes. So my next one's going to be blue, green. And then we have blue, red. And then we have blue, blue. And then we're going to follow it down again. And we're going to go green, green. We are going to then go green, red. And then we're going to go green, blue. And then we have, following it down, we have yellow, green. We have yellow, red. And we have yellow, blue. So this tree diagram gave us all the possible outcomes and combinations of colors that we could get in a turn. And once we have all the possible outcomes, let's count how many possible outcomes we have. We have 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. So there are 12 possible outcomes. We can answer questions like, what is the probability of getting a match? So we know the bottom number is going to be 12 because that's how many possible outcomes there are. And now we just have to go through and find the matches, or when the letters are the same. So we have a red, red here. We have a blue, blue. And then we have a green, green. So there's 3 favorable outcomes. 1, 2, 3. So the probability of getting a match is 3/12, which we could simplify that down to 1/4, which we know is 25%. There's a 25% chance of getting a match. Now, there's 2 different ways we could find the probability of getting a no match. We could count all the possible outcomes, all the favorable outcomes, or all the no matches, which would be 8/12, or 9/12, I'm sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. Which is 3/4, which is 75%. Or you could have also thought of the opposite of a match is a no match, and our probability should always add up to 100%. So if we have a 25% chance of getting a match, then we would have a 75% chance of getting a no match. All right, so I'm going to walk you through another scenario. Tree diagrams can be a little complicated, so I just want to make sure we are set. And I just want to make sure you know how to do it because it's very helpful with the outcomes. So there's a new $5 lunch combo meal at a restaurant. How many total possible meals are there? So if you feel confident about doing this, go ahead and do this problem now. Pause the video, do the problem, and then see if you get it right. If not, watch me do another one, and then go ahead and just practice this on our practice problems today. So we're going to have a start, and I'm just going to go down the list. So we can have one sandwich. So I'm going to label this sandwich. And we have 3 options for a sandwich. So we have chicken salad. It is okay if you abbreviate. We have turkey. And then we have grilled cheese. And we kind of want to spread those out because this is going to get a little muddled because there's going to be a lot of options. So there's our first 3 options. Now our second options are going to be our sides. So if I choose chicken salad, now I have to choose either chips, French fries, or fruit cups. So we have chips, French fries, or fruit cup. Same thing if I chose turkey. I have the option of chips, French fries, or a fruit cup. And then same thing with grilled cheese. Chips, French fries, and fruit cup. Now, we do have one more step to this tree diagram. So this is taking into account 3 different events happening. Sandwich choice, side choice, and our drink choice. So if I chose a chicken salad and then I chose chips, I now have the choice of either soda or water. If I chose French fries, I would still have the choice of either soda or water, soda or water. And we're going to do this for every single one again. Soda, water, soda, water, soda, water, soda, water, soda, water, soda, and then water. And now that we're done with all of our events, we can make a possible outcome list. So I'm going to label my list as possible outcomes. And then I'm just going to follow it through again. So I'm going to go chicken salad, and then follow chicken salad to chips, and then to soda. And then I have a chicken salad, chips, and water combo. There's a chicken salad, French fries, and soda, chicken salad, French fries, and water. Again, I'm just following this through. Chicken salad, French fries, soda, French fries, water. Chicken salad, fruit cup, soda, chicken salad, fruit cup, water. And now I have all of my chicken salads, so now I'm going to move to the turkey. So we have turkey, chips, and soda, turkey, chips, and water. We have turkey, fruit cup, or French fries, sorry, soda, turkey, French fries, water. Then we have turkey, fruit cup, soda, turkey, fruit cup, water. And now we're done with all the turkeys. So now we just have to do the grilled cheese. So we have grilled cheese, chips, soda, grilled cheese, chips, water, grilled cheese, French fries, soda, grilled cheese, French fries, water, and then we have grilled cheese, fruit cup, soda, and grilled cheese, fruit cup, water. So now that we have this tree diagram complete and all our outcomes listed, we can count them, and there's quite a few of them, which is why the tree diagram is helpful when labeling our possible outcomes, because there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 possible choices or possible outcomes. Or in this case, possible meals. So tree diagrams, even though they can get messy, make sure you label and organize. They're a great way to find your total possible outcomes for different situations and theoretical probabilities that have more than one event.